Okay, let's talk about adding and subtracting fractions. Now, for most of you, you've seen this and you've experienced this, and you probably are going to get this in about 3 seconds once I start talking about it, and that's great. If you don't understand this, and this isn't enough for you, there are probably other resources where you can go and look at it, and I would even suggest going back and looking at something from, 5th grade when they start teaching this. And I'm not saying this to be insulting, I'm being absolutely truthful, because that's they do a really good job of explaining it. This is just kind of the tune-up on that. So if you need more than a tune-up on this, then you talk to me or whoever your teacher is, and then we can get you that. So when you add and subtract fractions, the big thing is that your denominator has to be the same. All right, that's the denominator must be the same. You cannot do it if the denominator is not the same, because we have to be talking about the same number of units, subdivisions that where it works. All right, otherwise we're trying to subtract things that are different sizes from each other, and that just doesn't work. So in both of these problems that I have here, 2/5 plus 1/5 and 6/7 minus 1/7, these are both ready to go. And so when you have problems like this, the way it always works is, if you have 2/5, I'll just rewrite it out. Your denominator is going to stay the same. You're going to keep the same denominator. So I'm going to go 5 right over here, because that's what this one was and that's what that one was. You don't add them up and they don't become 10. You don't multiply them. You don't do anything. The denominator stays the same. And then you apply whatever this operation is to your numerators. So it's 2 plus 1. That's what you're doing there. 2 plus 1. So you have 2 plus 1, excuse me, which is 3 over 5. All right, so you have 3/5. Okay, and if you think about it, think about what 2/5 and what 1/5 looks like. So if we make a little tape diagram here, right, and I say, okay, this is 2/5 right here, right, and then I add one more fifth to it, which would be that, then you're left with 3/5, right? That kind of makes sense. You don't have 3/10. So just make sure you're not that's a very common mistake, and it's pretty weird conceptually, but if you're just looking at the numbers and you don't understand what it is you're doing, it's complicated. All right, so same thing with this one, 6/7, 1/7. You keep your denominator the same, and then you apply the operation that's in the middle to the numerator. So you got 6 minus 1, so it's 6 minus 1 over 7, which gives you 5/7. And if we do a tape diagram of this, right, and you start with 6/7, right, which would be 1, 2, 3, 4, 5, 6, and we say, okay, we're going to take one of those away. Sorry, that's what I meant to do. Then that leaves you 5 of them, and it's 5 out of 7. All right, 5/7. So let's look at what do we do when the denominators aren't the same. So you need to, the big buzz phrase here is common denominator. In other words, the denominator has to be the same. So the hardest thing, honestly, is just finding the lowest common denominator. In other words, a number that works for both. Now, when all else fails, you can always take this one and multiply them by each other, and you can get a common denominator. The problem with that is you will almost always certainly have to do simplification then if you do that. If you find the common denominator, the amount of simplifying you'll have to do is minimal, if not none. All right, so I look at 3 and 9, and the number that they both go into, that's the smallest, is 9. So if I'm going to convert 1/3 to something ninths, right, I look at what am I doing to 3 to make it 9? Well, I'm multiplying it by 3. So then I'm going to do the same thing to 1, right? I'm going to go 1 times 3. That's going to give me 3 right up there. This one is already ninth, so it becomes 3/9 minus 2/9, right? So your 9 goes on the bottom, 3 minus 2 on top, so it gives you 1/9. All right, 3/8 plus 1/6. So the lowest common denominator for that I can think of, I believe, is 24, right? Because 8 goes into 24 3 times, 6 goes into 24 4 times. So let's put 24 down for both of these. Let's put our plus sign. In order for 8 to go to 24, you would have to multiply it by 3. So we're going to do the same thing to the top. We're going to go 3 times 3. That's going to give you 9. In order for 6 to go to 24, you would multiply it by 4. So we have to do the same thing to the top. So 1 times 4 is 4. And then 9 plus 4, which is on top. The 24 stays on the bottom. And you wind up with 13 24ths. All right, I hope this is making some sense to you guys. Now, when you have negative numbers, it's the exact same thing. You're just going to kind of apply some of those integer rules to the signs, but it's same game, right? So negative 4/5, and then you're adding negative 1/3. Well, lowest common denominator in this one is actually when you multiply them together, which is 15. All right, so 15 and 15. I know this one's going to be negative, this one's going to be negative. 5 gets multiplied by 3 to make 15, so we're going to multiply 4 by 3, and that's going to give me 12. And then 3 gets multiplied by 5 to become 15, so we're going to multiply 1 by 5 to give us 5. So then what you have on top, and this is a little weird, but you get 15 on the bottom, and then apply these signs to the ones on the top, right? So you get negative 12 minus 5. Now, if you don't remember how to do that, rewrite it as negative 12 plus negative 5. So the signs are now the same, and it's an addition problem. And when the signs are the same, you just add them up and then keep the common sign, which is negative, and you have negative 17/15. And in a lot of these problems, Alex is going to let you leave them as improper fractions. But if they wanted you to change this, you would realize 15 goes into 17 one full time. You're left with 2 left over, right? Because 17 minus 15 is 2. And then your denominator still stays 15, and this whole works was negative. So negative 1 and 2/15. All right, this last problem here. Common denominator. Well, 5 actually goes into 20. So we don't need to change 17/20ths. And then we'll change this 1 over to 20ths. You do that by multiplying it by 4. And you multiply 2 times 4, and you get 8. It's negative. So then you have negative 8 plus 17. So when the signs are different, you go 17 minus 8, you get 9. And then you take the sign of the number with the larger absolute value, and that would be this one right here. So you wind up with 9 over 20, and you have your answer. So I hope this is helping you. This is difficult for a lot of kids, but it's really important to become kind of comfortable with this. Most of the numbers you deal with in real life are fractions and decimals, not integers. So this is a skill you will use later on. So